Hey guys, in today's lesson, we'll be writing one variable equations and inequalities. All right, let's look at some definitions real quick here. An equation is a mathematical statement composed of algebraic and or numeric expressions set equal to each other. So once again, it's just algebraic or numeric. It's just any problem that says with an equal sign. For example, like 3 plus 5 equals 8. That's an equation. Algebraic, they're saying something like 3x plus 2 equals 10. Once again, big thing is that equal sign. Inequality. A mathematical statement composed of algebraic and or numeric expressions set apart by an inequality symbol. So, once again, same thing, definition, except inequality, you can have less than, greater than, less than or equal to. It does not have an equal sign. All right, a variable is a letter or symbol that represents a number. So an example here is, if you watch here, we've got variable. It shows it as the x. Once again, it can be any letter. I can call it A, I can call it B, I can call it D. It really does not matter. The letter I give it can also be indicated by a symbol. Usually when just in basic algebra, we use letters. We don't use symbols. The further in math you go, you might start using Greek letters or Greek symbols. But it's just a symbol that represents a number. And these guys are numbers. They're unknown numbers, what we call them. And sometimes we can't find them, or most of the time we can't find them in algebra. Coefficient is a number that is multiplied by a variable or variables. So it's just a number that sits in front of the variable. The number that sits in front of, in this case, the x value. The 3.2 here would be the coefficient. Over here would be that 4 over 7. Once again, it's sitting or being multiplied right to that variable number. Constant. A constant is a fixed value that does not appear with a variable. So, for example, in this example on the left, we see 12 as a constant because it's just a number, a known number, that is not next to a variable. Same over here, this negative 4/5 would be a constant. Or in this inequality, on the right-hand side, we see that the 6 is a constant, or the positive 2 is a constant. And once again, numbers that are known that do not sit next to a variable. Equality and inequality words and symbols. So, for example, equal to. It's shown with this sign right here, equal. Example in words, x is equal to 4. Or in symbols, just x equals 4. Greater than. Once again, it's a sign opening up. So x is greater than 4 in words. Or x is greater than 4. When we say x is greater than 4, we're saying x is something like 4.1, 4.2, 5, 6, 7, etc. Just greater than 4. Greater than or equal to. Once again, indicated by a sign where we got this little alligator mouth as an example, opening up, and a little line under indicating that it's also equal to. So x is greater than or equal to 4. So once again, symbols, x greater than or equal to 4. And once again, this one is also indicating that we can also be 4 as well. So we can be 4, 4.1, 4.2, 5, 6, anything that's just greater than 4. And also equal to 4. Less than, usually indicated with this little symbol right here. So x is less than 4. Example in words. X, well, the alligator mouth is now opening towards the 4 because the 4 is the bigger number. So x is less than 4. Less than or equal to. Kind of the same thing as greater than or equal to. We just have that little line underneath indicating that we can be the number as well. So x is less than or equal to 4. X less than or equal to 4. Once again, less than or equal to, so we can be 4, but we can also be numbers such as 3, 2, 1, 0, etc. Not equal to. Indicated with an equal sign but with a slash going through it, saying we cannot be that number. So x is not equal to 4. Symbolically, it's just x not equal to 4. All that's pretty much saying is we're not the number 4. Let's not forget about our order of operations. They are the rules of which calculations are performed first when simplifying an expression. We usually call it PEMDAS. We go by the order of PEMDAS. So we do parentheses and brackets first, then exponents, then multiplication and or division, and addition and or subtraction. All right, let's look at some examples here, writing some equations or inequalities. So it says, Macy's cell phone bill costs $24 each month, plus 15 cents per minute. Macy's cell phone bill for the month was $101.25. Write an equation to determine the number of minutes X Macy used during the month. So we're going to let X represent the number of minutes that she talked. Okay? So going back to this first sentence where it says Macy's cell phone bill costs $24 each month. So that's a given value. It automatically costs 24. So we know it's going to be 24 plus, once again, 15 cents. And keyword here, when we hear that word per, it usually indicates a variable. So 15 cents per minute. So once again, we're letting X represent every minute. So $24 plus 15 cents times however many minutes she talked equaled $101.25. On this lesson, we're just learning how to set up the equation. So we're not going to solve on this one. In the future, we may solve these guys right here. So we're not going to actually solve how many minutes, but we do know that $24 plus 15 cents for every minute she talked equaled $101.25. So that would be the equation. Let's look at another one. Blake has $25 from his allowance. He spent $13.54 on a video game. He also wants to purchase gummy bears that are 89 cents per package. Write an equation to show how many packages of gummy bears he can purchase. X if he spends all of his allowance. So we're going to pretend that he spends all of his allowance. Once again, we're letting X represent the number of gummy bear packages. So he spent $13.54 on a video game. That's a known number. And plus, because he also bought some gummy bears, so $13.54 plus, because we're adding on how many gummy bears he bought, or packages, 89 cents. Once again, here that keyword per, we usually attach a variable. So $13.54 plus 89 cents times X, or per package. And we know that equaled $25 as he spent all of his allowance, and that's the amount that he had in his allowance. So this would be the equation right here. Okay, kind of the same examples, but now we want an inequality. This one says Macy's cell phone bill costs $24 each month plus the 15 cents per minute. Macy cannot spend more than $120, probably because that's the max amount that she's got to spend per month for her cell phone bill. Write an inequality to represent the relationship between the number of minutes Macy can use each month X and her total cell phone bill. So kind of the same thing as we did before when we talked about Macy's cell phone bill. But we know she has to spend $24 each month. So 24 plus the 15 cents per minute. Once again, allowing X to be or represent the minutes that she talked. So once again, 15 cents times how many of her minutes she talked. We need that amount there, the amount that she spends, to be less than or equal to 120, because that's the max that she spent, $120. So we want the equation part, what she spends, to be less than or equal to 120. Once again, the sign indicates that it is less than. The 120 has to be greater, hence why the alligator mouth is opening up towards it. Okay. Blake has $25 from his allowance. He spent $13.54 on a video game. He also wants to purchase gummy bears that are 89 cents per package. Write an inequality to show how many gummy bear packages he can purchase X without exceeding his allowance. Once again, we know he bought a video game for $13.54 and, or plus, 89 cents per package of gummy bears. Once again, X representing per package. We don't know how many packages he bought. We're going to represent that with X. X representing the amount of packages. So the total cost would be $13.54 plus 89 cents times how many of her packages he bought. Well, once again, he can't go over his allowance, so it needs to be less than or equal to his total allowance of $25. So this would be our inequality right here. See, we're not solving yet. We could solve and see how many gummy bear packages he could buy. We'll do that in another lesson. Okay. Miss Stevenson and Mr. Mize took their classes to the Wildflower Center. Miss Stevenson had 15 children in her class, and Mr. Mize had 18 children in his class. The admission of all the children is budgeted at $251.46. So when they say budgeted, that means that's the max they can spend. Write an inequality to determine the admission price, X, for each child that could be paid without exceeding the budgeted amount. Determine if an admission price of $7.59 would allow both classes to visit the Wildflower Center and remain under their maximum budget. Well, first let's look at the equation. Let's go ahead and let X represent the number of children, let's let X represent the amount for the admission ticket. Okay. Because we know we're going to have to pay for each child. Well, in Mrs. Stevenson's class, she had 15 children. So we're going to take her 15 children and multiply it to the admission, or 15 times X in this case. Once again, X represents the price of the admission ticket. So 15 times the price of the admission tickets. Well, then we also got Mr. Mize's children, so we got to add the 18 students he has times the price for the admission ticket. Okay? So all in all, we've got 33 kids here paying admission, and we need it to be less than or equal to the total amount budgeted, $251.46. So this would be our inequality right here. Once again, it does ask us if the admission is at $7.59, would allow both classes to visit the Wildflower Center. So now they're giving us an amount for the admission, so we can replace that $7.59 in for the X. So if we go 15 times $7.59, the price of the admission, plus Mr. Mize's kids 18 times $7.59, we multiply through 15 times $7.59, we get $113.85, and 18 times $7.59, we get $136.62. Add those two amounts together, we do get $250.47. That number is less than $251.46. Therefore, the admission tickets did cost $7.59. The children would be allowed to go because we do have enough money. Okay, next problem. Okay, in this one, 1 second here, guys. Sorry about that. It says Jake and his two brothers bought a present for their grandmother. If the total cost of the present was $42.33, write an equation that could be used to determine C, the cost per person. Well, once again, we're letting C be the cost per person. So C equals, or the total cost per person equals, well, in order to find this, we take the total cost and divide it by the number of people. Once again, makes sense because you take the total cost divided by the amount of people, you'll get how much each of them pay. So in this case, C is equal to, well, we know what the total cost is, $42.33. And dividing by the number of people, well, there's Jake and his two brothers. So there's Jake plus his two brothers. So the total number of people is 3. So to find the total cost, we just take, to find the total cost per person, what they pay, C, is equal to the total amount divided by the number of people. Pretty easy. All right, moving on to the next one. Jake's paddle boat rides charges $5 per person plus $3 for every 15 minutes that a paddle boat is rented. If 2 people rent a paddle boat and pay $250, which equation can be used to represent X, the number of hours a paddle boat was rented? Okay. Let me grab this real quick. So once again, we're trying to create an equation. So an equal, not an inequality, just we're trying to equal. Jake's paddle boat rides charges $5 per person plus $3 for every 15 minutes. What we're trying to establish is if two people, only two people, rent a paddle boat and pay $250 total, that's our total, which equation can be used to represent X, the number of hours. Okay, number of hours. Alright, so real quick, what I'm going to do is I'm going to find out how much it costs me per hour. Well, since it's $3 for every 15 minutes, well, there's a total of 60 minutes in an hour. And I understand that's $3 for every 15. Well, real quick, I'm going to divide by 15 to see that we've got 4 sets of 15 minutes, or 15 plus 15 is 30, plus 15 is 45, plus 15 is 60. So, and once again, it's $3 for every 15 minutes, so 4 times 3 equals 12. So it's going to cost me $12 for every hour. Once again, I'm trying to find that because X is representing the number of hours. Alright, so once again, Jake's paddle boat ride charges $5 per person, so writing this equation, we go $5 per person plus $3 for every 15 minutes, or $12 every hour. So 12 times X, the unknown. Once again, letting X represent the number of hours. And we know it's equal to, in this case, if 2 people rent it. So we're not going to say per person anymore because we know 2 people. So real quick. So 5 times 2 people per person plus 12x equals, when we know they spent $250. So real quick, let me rewrite that. So 5 times 2 people, because $5 per person, so 5 times 2, plus $12 times x, aka per hour that they spent, and we know it's $250. Alright, so there's our equation. Once again, we're not going to solve and see how many hours they spent. We may do that in another lesson. Right now, that would be our equation. Okay, once again, $5 times per person plus $12 per hour. Once again, X is representing per hour, and we know it equals $250. Okay, next question. A department store advertised a pre-holiday sale for ovens in the newspaper. A $500 oven may be purchased by putting $80 down and paying off the remaining balance in 12 equal monthly payments. Using N as the amount of money in each monthly payment, write an equation that could be used to determine N, the amount of each monthly payment. Okay. Again, not solving, just trying to figure out the equation. So we know that $500, or the total price of the oven, is equal to, well, the $80 he puts down plus the 12 monthly payments of whatever amount that he has to pay. And we're going to represent that with N. Once again, N is the amount of each monthly payment. Once again, we don't know what the monthly payments are. We're trying to figure that out. We're letting that represent N. Once again, 12 times N. Because if we took his monthly payment and multiplied it by 12, the 12 equal payments he has to pay, and we add it to $80, we know it should equal $500. So this would be our equation right here. Okay, hope that made sense. Let's move on to the next one. Kathy works at a warehouse packing boxes. Her job is to place P items. And I'm going to go ahead and write. So she needs P amount of items, once again unknown value, indicated by a variable, that each weigh 2 kilograms. So each item weighs 2 kilograms into a wooden box that weighs 1 kilogram. So we do got to account for the box that weighs 1 kilogram. If Kathy can lift a weight of up to 10 kilograms, so it means she can lift up to it, which she can lift 10 kilograms or less than, which inequality, now we're writing an inequality, represents the number of items Kathy can place in each box and still be able to lift the box. All right, once again, we're going to allow P to represent the amount of items in the box. Okay. Looking at her thing, her job is to place P items. So P, then each weigh. So 2 kilograms. So we know they both weigh 2 kilograms. So 2 times P, or 2 times the amount of items, plus the 1 kilogram. Okay, that's so far the equation. That represents the weight in the box, 2P plus 1, because 2 times the amount of items, which is, once again, each item weighs 2 kilograms, plus the box, which the box is 1 kilogram, has to be less than, or at least equal to, the total amount that Kathy can lift, which you can lift up to 10. So there's our inequality right there. Okay, once again, this is the part for the weight in the box. The 10 represents the amount that she can carry. So we don't need the amount of the weight of the box to be less than or equal to 10. Okay. Next question. Hopefully I explained this one a little bit better. Let's see here. Ellen purchased some pencils for 45 cents each. Once again, that's a keyword for me, each. Usually that indicates we need to attach a variable. She also purchased a ruler for $1.60. Ileana spent more than $1.75 on the ruler and pencils. Which inequality can be used to find P, the number of pencils that Ileana could have purchased? So once again, P is representing the number of pencils. We need to write an inequality that can represent this situation. So Eliana purchased some pencils, so we need number of pencils plus ruler, and she spent more than, so we need this to be greater than, because she spent more than it, or at least, not equal to. It tells us she spent more than $1.75. Okay, well, number of pencils. Not just number of pencils. P represents number of pencils, but the cost of pencils. Go cost of number of pencils. Okay, well, we know each pencil cost us 45 cents. And the total cost of pencils will, of course, be that 45 cents times the amount of pencils she bought. So we're once again, P represents the number of pencils plus her ruler of $1.60. And we need that to be greater than $1.75. Okay, so there's our inequality right there. 45 cents times the number of pencils plus $1.60 for the ruler has to be greater than $1.75. Okay. Next one, last problem. All right, it says the Lincoln Middle School football team needs to raise they need at least this much, $1,225 for new uniforms. They sell tickets for a school dance for $2 each, but they have to pay the DJ $500. Create an inequality that the football team can use to see how many tickets they must sell to reach their goal. Okay. Well, in this case, let's let T represent the number of tickets they sold. Or number of tickets they need to sell. Okay. We're looking at an equation here. They sell tickets for $2 each, but they have to pay the DJ $500. So we need their profit, or we need, their profit of what they made to be greater than or equal to the new uniforms, the cost of the new uniforms. And that's what we need. All right, well, let's find the profit. Well, the profit is, of course, $2 for each ticket they sell. So $2 times T. Once again, T represents the number of tickets. So we're multiplying because we don't know the number of tickets, and we're also multiplying because $2 for every ticket. So, we get one ticket, it's $2, two tickets, $4, three tickets, $6. Once again, just multiplying by 2. But the profit, of course, is $2 for each ticket, but minus $500 for the DJ because they have to spend that money to get the DJ. So minus $500. So we need that to be greater than or equal to the cost of the new uniforms of $1,225. All right, so there's the inequality. All right, guys, like I said, in this lesson, we're just setting up the equations or inequalities. We're not going to solve. We'll do that in the future. All right, that's the lesson for the day. Hopefully y'all learned something. Y'all have a good day.